everyone, this is Mrs. Hunt, and today we're going to be doing Unit 3, Lesson 9 on quadratic functions. So this is going to be page 99, and let's go ahead and get started. So, alrighty. So here we have, at the heart of solving any inequality is finding all values of the variable or variables that make the inequality true. So this basic notion of inequalities is really critical in understanding before proceeding anywhere. So again, the heart of solving any inequality is finding all the values, okay? So for the first one here, it says, determine if each of the following is a solution to the given inequality. Show our work to justify our answer. So we're just going to go ahead and substitute in the number 4 for all the x's. And then we're going to grab our calculator and we're going to type that in, 4 squared minus 3 times 4 minus 10, and we're going to get an answer of negative 6. Now, is negative 6 greater than 0? No, it's not. So this is not true. Okay? And we'll do the same thing for the rest. Okay, we can either put true or false, or we can kind of put a little check mark or cross out the inequality symbol to denote that it's not true. Okay, and then for this last one, we just want to be extra careful when we have negatives, that we do have the negative in a parenthesis and the square on the outside. And this one, of course, we had to have one kind of tricky like this, where they give us the same number on the left and on the right side. Now this says 0 is less than 0, which is actually false because there's not a line underneath it saying 0 is less than or equal to 0. So this is not true. Okay, so we're just determining if the number that we are given is a solution to the inequality. So this one was true, these ones were not. Alrighty. So here it says, most of the time there are an infinite number of solutions to an inequality, because an inequality symbol is like, this is less than this. So all the numbers less than infinity, or all the numbers bigger than, okay, in a particular solution set. So the solution set of an inequality like these can be written in a couple forms. One form is called a roster form, where we list out the solutions. So that's what we're going to kind of do in exercise, in this exercise here. It should say exercise 2, and they're misnumbered here, so that should be 2. So it says, consider this inequality. It says, solve the corresponding equation algebraically for all values of x. So see how all that we've done is change the inequality symbol to an equal sign? It's very similar to what we just did in the last lesson. So we're just going to treat this as if it were an equal sign versus an inequality symbol, and we're just going to factor it. Remember, how do I know that we need to factor it? Well, I can't add those x's together. So if I can't add those x's together, I must have to factor it, so I could break apart those x's and then figure out the corresponding numbers that go in there, positive 3 and negative 1, and then our corresponding answers. Okay, it says here, using your calculator and the equation, fill in the table. So we're going to go ahead and put that in, x squared plus 2x minus 3, and we will put that into our table. So you have negative 5, that corresponds to 12, 5, 0, negative 3, negative 4, negative 3, 0. 5 and 12. Okay? So it says explain why the zeros we found in part A are not part of the solution set of the inequality. So it says to solve the corresponding equation, which we did for values of x, using our calculator and the equation, fill in the table. And now it says explain why the zeros we found in this part are not part of the solution set. So we have to remember that these numbers here give us an answer of 0, right? We see them. Okay, so here we solved algebraically for those values, and here we got those values and verified them from the table. But we have to really make sure we go back to the original question, because we want to know the values where it's less than 0. So -3 and 1 cause the cause the inequality to equal 0. However, the answers should be less than 0. That's what we want. We want to know the values of x that will cause this right side or this left side to be less than 0. Those are going to cause it to equal 0. Oops, sorry guys. So here it says write the solution set of the inequality using what we call set builder notation, and then also represent it on a number line. So if we take a look here, this is not less than 0, this is not less than 0. The numbers that are less than 0 are the ones in between, okay? But we also have to make sure we use these numbers. So that's why it's important that we find them, but we're also going to be utilizing them. So we're going to say everything in between -3 and 1. But notice we don't write the line underneath it, because we don't want to include them in the answer, because they're not. They're where it's equal to 0. But the reason why we do want to use them instead of -2 and 0 is because what about -2.5? What about -2.999? What about 0.999? Those small numbers and decimals just right before these we have to include. And if we start with if we have -2 here and 0 here, we're excluding all of those values that are in our answer. And then we want to go ahead and represent it and write it on a number line. We have -3. We're going to have an open circle because there's no line, and we're going to shade in the middle. Okay? And for our question here, it says the key to algebraically solving a quadratic inequality is first to find the zeros, which is why we did that up in exercise 2A, and then test points between the zeros inside and outside. So here it says which of the following is in the solution set. So the first thing we're going to do is we're going to change it to an equal sign to find the zeros. So this is why we did what we did before. Now this is a dots question. We have x plus 2 and x minus 2. And when we solve and set each parenthesis or each factor equal to 0, we subtract over the 2. We add this 2 over here to get these two values, okay? So if we were to go ahead and put this on our number line, then what we're going to do is, again, notice how it's there's not a line underneath it. We're going to go ahead and put open circles. So whatever the symbol is in the question will be for both of those circles right there. So if it was a line underneath, they'd both be colored in. If obviously it's not a line underneath, they're both going to be open. It's never going to be 1 and 1, okay? And then what we're going to do from here is we're going to test a point. So as you can see, I put a 0 in the middle. I usually put the 0 in there, but you could also pick a number on the outside. I just always test 0. It's the easiest thing to test. So no matter if it's on the inside or outside, I test a 0, and if it comes out to be a true statement, then I color over the 0. If it's a false statement, then I shade around the 0. So for instance, I'm going to go back up to the original and plug a 0 in for x. What's going to happen if I plug a 0 right there? I'm going to get this. So is that true or false? Is -4 bigger than 0? Nope. Okay, so that means 0 is not a solution, and our answers are this way instead of in the inside. Okay, which means our answer is an or this way or this way, instead of having the answers or the shading be in between the two numbers. So this is when the shading is in between because our x is in the middle, and this is when they're either way. Okay, so we're going to be doing a lot more questions that are exactly like this, where we're going to step 1, change it to an equal sign, step 2, factor, and step 3 to solve, as we normally did. That's what we did the past couple lessons. But now what we're going to have to do is, because it's an inequality symbol, we're going to have to graph it and then do a test point so we could shade it. And then we have to write our answer. Okay? So there's a lot of different things that we're going to need to do to make sure that we get this question correct. All right, let's take a look at the next page. Okay, so here it says solve each of the following quadratic inequalities, write our final answer in what we call set builder notation, and represent it on a number line. So we're going to have to do a couple different things there, okay? So first things first, step 1, change it to an equal sign. This is a temporary change, but we don't want to be fussing around with inequality symbols. We want to know where it's going to be equal. Sorry guys, let me see if I can. There we go. I want to know where it's going to be equal, okay? So that's my first step, and then I can decide whether the solution is in between those two numbers or in opposite directions. So we're going to say what two numbers multiply to be 36 that add up to be 12, or add up to be, or subtract to be 5. So if I take 36 and I divide by 3, I get 12. So I'm going to have 12 and 3. Let's see if this is one. Now remember, if we're still practicing our factoring, we can go ahead and write all the factors of 36. 1 and 36, 2 and 18, 3 and 12. What else do we have here? We should have 4 and 9, and I think just 6 and 6. So yeah, 4 and 9 and 6 and 6 are the only two. So now we want to figure out how we're going to get to a 5. Well, 12 and 3 are probably not going to get there, because if we subtract them, that is not going to, for some reason I was thinking 15 and it's actually a 5. So we want to use 9 and 4. So a -9 and a +4 is going to get us to add up to be that -5, and multiply together to be that -36. And then we're going to go ahead and write the opposite as our answers. Okay? And now we have to make sure, now this question was not an equal sign, so we're not done, because we now need to put those on the number line. Find your 0, okay? You need at least 3 numbers on your number line, so you have the 2 numbers from your question and your 0. And then look at the symbol above. That's has a line underneath it, so you're going to go ahead and have closed circles. And now we're going to test 0. So again, this is the easiest thing. If I plug a 0 in for x's, those are gone. And I get this. And I say to myself, is -36 less than or equal to 0? The answer is yes. So because it's true, I'm going to be shading over the top of it. Okay? So that is my number line that I have done. And now I need to write my final answer. I always write my graph first, and then I write my answer from my graph. So that's a key point. So my answer, I shaded in the middle. So my answers are in the middle, okay? And then the symbol will always be this way. Not because that's how it started here, but that's because that's how we write this. x's are bigger than -4 but less than 9. So it's facing the x in relationship to the -4 and facing away from when it's in relationship to the 9. So these are the two answers that we are asked to write. Okay? All right, we'll just keep practicing, but this is the exact same steps we're going to follow for all of these. So we're going to temporarily change it to an equal sign. We are going to factor by looking for first GCF, which we don't have, and then we notice it's a trinomial, so we're going to have our guess and check. We have our factors of 12, 1 and 12, 2 and 6, 3 and 4. And we need to figure out where, which ones we can utilize. Now there's no, all guesses will be intelligent guesses because we don't have any factors with 5 in it. So we just need to try to get to a 12 with our answers here. So, or not a 12, a 28. So we're trying to figure out how do we add or subtract our inside times inside and our outside times outside to get to a 28. So I am thinking that if I pair the 6 with the 5, that gives me 30, and then the 2, and I can subtract those two. So 5 times 6, I need this to be a positive 28, and then a minus to make it a 30 minus 2 to be a positive 28, and they multiply together to be a negative 12. So I'm just going to erase that. You might want to do it off to the side if you're using pen, so you don't mess up your work area if you can't erase it. And then again, this is equal to 0, so now each part gets set equal to 0. And we solve. We're going to add over the 2 and divide by 5. And here we're going to subtract the 6. So these are the roots that we're looking to use, and that's where we start our number line. So again, you always, once you have your numbers, you're going to do your number line. Now here's where we want to be careful. We have to do the number line correctly. Just because this number is written or found first doesn't mean it goes on the left side. So -6 is lower, lowest goes on the left, then find your 0, and then 2/5 is just going to be like super close to 0. It doesn't need to be a super accurate number line. You have to have 3 tick marks on your number line. Make sure you use the 2 values and 0. That's all. Okay? So now what we're going to go ahead and do is on our 2 roots there, we're going to go back up and look, and those should be open circles. So we're going to put open circles on them, and we're going to go ahead and plug a 0 in, or just cover up the x's. And look at this right here to determine if we shade in the middle or if we shade towards the outside. So is -12 bigger than 0? Nope. So I'm not going to be shading over the 0. I'm going to be shading away from the 0. Okay? Now, how do we write the answer if it looks like this? Similar to the multiple choice problem, we have to say that our x's, take this arrow that you drew. That's literally the same arrow, the same symbol you're drawing, okay? With the -6, then you write or, and then you write your x, and you look at this arrow. See how you drew this arrow? That's the same way you draw that arrow. And then you put your number. And that is your answer. Okay? So it's super simple and easy just to utilize the arrows to make your inequality symbols, but it's only if you make sure that you have your numbers in the right order. Don't put 7 over here and -2 over here. That's silly, okay? So notice for the next 2 problems, we have stuff on both sides. Just as before, we need to get everything over and equal to 0. So step number 1 is we're going to change it to an equal sign. And then get everything over equal to 0. So I'm going to subtract the 10 and add the 8. So subtract the 10x and add the 8. and I add down on this side. Just so happens that those are opposites and they cancel. Doesn't always, just happens in this case. So what we're going to go ahead and do is we now have to factor. Now this is no longer a trinomial, it's a binomial, but it's a GCF. So it's not going to be dots. 14's on a perfect square. This doesn't have a positive of an even exponent. So this is going to be GCF. We're going to GCF out a 2 and an x, and then we're going to divide and take away an x, divide by 2, take away an x. And that's going to allow us to have these parts right here. Dividing by 2 gives us a 0, and then we add over the 7, that gives us a positive 7. You guys can see this. That's a bit better, the lighting. Okay. So what we want to do from here, now this is tricky because we have our 0 and normally that's the number we add. So we just have to add a third number, a different number to our number line. So let's draw a number line. We have 0, let's add a 1 and a 7. Literally doesn't matter what number you have. I chose a 1 because it's just going to be the easiest to work with when we type in what we need to in the calculator. So what we're going to go ahead and do for this question is we need to go back up and look at the top, and we're going to say we have a line underneath. So at both of those we're going to have a closed circle. Okay. And now what we're going to go ahead and do is we have to test a point, and that's why I picked the 1, so I'm going to test that point. So when I go ahead and test that point, I'm going to plug it into the equation. So this is what we're going to do. We're going to plug a 1 into the left side. And we're going to plug a 1 into the right side. And we get negative 10 bigger than or equal to 2. So is negative 10 greater than or equal to 2? No, it's not. That means that 1 is not an answer, so that means our answers are around it in this opposite direction. So that's how we're writing our arrows. Okay? And then we're going to go ahead and write our final answer. As we said before, it's X symbol with the number, X symbol with the number. Now notice this one is different than the other one just because the original question has the line underneath. So we have to have that all the way through. Okay? So again, step number 1, change it to an equal sign. Step number 2, make sure it's equal to 0 so you can factor it. So in this case, we have to move it over. What ends up happening in this case, which it doesn't always, like I mentioned, these end up canceling, and when I add those together, I get 2x minus 25. And again, I just have to think about the different types of factoring methods that we've gone through to factor it. This is the difference of two squares. This is dots, so it is conjugate pair. We're going to solve. We get x to be equal to negative 5 and positive 5. And so that's what we're going to choose to use on our number line, a negative 5 and a positive 5. And then we're going to go ahead and see, plugging in the 0, what we'd get. So again, like I said, this is the easiest thing. If we plug in a 0, those are gone, and we get negative 6. And if we plug a 0 over here, that part is gone, and we get 19. So this one was the hardest because we actually had to plug in the 1 into both sides and like look at a new inequality. But when we are able to use a 0, we when we're able to use a 0, we can just kind of cover up the x values. Don't cover up the sign in front of that number, but cover up those x values and say, is -6 less than 19? Yes, it is. So that means, I forgot my circles, that means that 0 is a part of the solution since I got a true statement. So I'm going to go ahead and make sure that those are connected. And how do we write this answer? We're going to go ahead and say, well, all the answers are in the middle of -5 and 5. And as I mentioned before, it is always this direction, always, always, always when we're writing it this way. And it's just dependent upon this original symbol, whether we put the lines underneath it. In this case, we don't. Okay? So this is what we're going to definitely continue to practice. It has a lot of concepts that come together. And it's very important that we know how to solve these. All right, let's take a look at number 5 here. So number 5 says, the number line graph is the solution to which of the following inequalities? So I'm just going to write some numbers in here. This is a -4, and this is a +2. And the first thing I notice is that they are closed circles, so 1 and 2 are out. Okay? And then a couple different things that we can do with this. We can take those roots, like if x was supposed to equal -4 and x was supposed to equal +2, we can put them back in the parentheses as the opposite signs and FOIL. First times first, outside times outside, inside times inside, and last times last to get to what we would see in the middle, a +2x. Okay, so that's just one way to do it. You could also take take the 0, see how we shaded over the 0. If we plugged a 0 in, it would we could compare. Okay, if we plugged a 0 in, because it's shaded, is -8 greater than or equal to 0? No, that's false. So that's why that's out. But -8 is less than 0. So that way that should be in. That's true. Okay. And then the last question here, which of the following represents the solution set of the inequality? So this again is tricky because we have a negative sign in front. So if you watch the last lesson, what we did was to get rid of that is we multiplied both sides by a -1 so that we didn't have to factor with a negative. We absolutely can do that in this case, but we have to be careful because you should remember that when we multiply through by a -1 and we multiply over here by a -1, when we multiply or divide by a -1, the symbol will switch directions, okay? So we just have to be careful that we switch the inequality symbol. So that we'd get +2x squared minus 7x plus 3, flip the symbol, and now there's our 0, okay? So that is absolutely 100% good math to do. We just need to make sure to change this symbol direction. So now let's go ahead and change it to an equal sign and factor. So this is a guess and check, but it should be an easier one because of these prime numbers. I'm going to pair the 3 up with the 2, and then I'm going to need to have both of them be our negative signs, because a -6 plus a -1 is going to get us to the -7, and a -1 and a -3 will get us to our +3. So we did do that correct. We checked it. We made sure we did it correctly. And now as we do our t-chart, we say our x is equal to +1/2. Remember, we're adding the 1, dividing by 2. And here we are adding the 3. So these are our roots, but notice, okay, so this one is not right, and this one is not right. So we can at least cross both of those off as choices. And now we just need to determine, are they shaded inside or shaded outside? So let's go ahead back to draw our number line. 0 is going to be right here. 1/2 is going to be on this side of 0. And then over here it's going to be 3. So we just have to watch out for this particular problem. So if we do plug a 0 in and it's true, we actually need to shade over the 0. But let's first put our open circles. Because of that's an open circle, put the open circle there. And now, like I said, no matter if it's inside the two numbers or outside the two numbers, I'm going to test the point 0 because it's the easiest to test, okay? So if I go ahead and I substitute the 0 in for these two, I get -3. -3 is greater than 0. Is that true? No. -3 is not greater than 0. Okay? And even if I go into this one and I plug a 0 in for these, this says 3 is less than 0. Positive 3 is less than 0. So that's also not true. So either way, it doesn't matter which one you plug it into. This was false, which means I do not shade over anything that's false. I'm shading over the other area. So it's always either shading in between the two numbers or shading outside of the two numbers. It's never shade here and shade here. It's always either inside or outside, okay? So that means that this must be the answer because our x's are in the middle of both of those numbers, okay? So make sure that if you need to pause this or go back to it, you get this down. This is an extremely important topic because, I mean, notice how much work goes into every single question. These are going to be worth the most on quizzes and tests. And if you need help with this, please rewatch the video. Please make sure that you are staying after with me or asking questions during class. Okay, guys? Have a great night. We'll see you later.